Hello everyone, myself is Asmiya from the Department of EEE. Today I am here to present a topic on logic gates. Then coming to the topic of logic gates are the basic building blocks of any digital system, and it is an electronic circuit having one and more than one input and only one output. The relationship between the input and the output is based on a certain logic, and the logic gates are used to perform fundamental operators in digital electronics, including arithmetic and logical functions, and also data processing and data storage. Then coming to the classification of logic gates, they are divided into three types like basic logic gates, universal logic gates, other logic gates. Under basic logic gates, AND gate, NOT gate and OR gate. Under universal logic gates, NAND gate and NOR gate. And other logic gates are XOR gate or XNOR gate. These are the symbols of all the gates, and these logic gates are the fundamental building blocks of all digital electronics and powering everything from simple household gadgets to complex computers by performing basic decision making operators. Logic gates. These gates are the fundamentals building blocks of digital circuits and processing binary inputs and produce a single binary output based on a specific logical rule. And the first gate is AND gate. The output of AND gate is high, that is 1, if all of its inputs are high, that is 1. And the output AND gate is low, 0, if any one of its input is low, then it is 0. And its ability to enforce a condition where an output is produced only when all inputs meet a specific requirement. Here is the AND gate logic symbol. Its logic is it has two inputs and it get one only output, and the outputs one only when all of its inputs are 1, otherwise the outputs is 0. Then coming to the truth table, this truth table has two key points. The output is true or else 1 only if both inputs are true. For all other combinations of inputs, the output is false and also call it as 0. And this one is OR gate. The output of OR gate is high, that is 1. If any one of inputs is high, we take it as 1, and the output of OR gate is low, we take it as 0 if all of its inputs are low. And then this OR gate plays a crucial role as a building block in digital electronics, where it performs the logical or operation producing a high output if any one of its inputs are high. Here it is a logic symbol of OR gate. This OR gate logic symbol is a curved shape with two inputs on the left and one output on the right. Then coming to the truth table, its output is high, that is 1, if at least one of its input is high, and low is 0 only when both of its inputs are low. Then coming to the NOT gate, the NOT gate is fundamentally important in digital electronics for the following two steps, that is implementing logic operators and controlling and selecting signals. And the output of NOT gate is high, that is 1, if its input is low, that is 0. The output of NOT gate is low, that is 0, if its input is high, that is 1. It is clear that NOT gate simply inverts the given input. Since NOT gate simply inverts the given input, therefore it is also known as inverter gate. And here is the logic symbol, and the truth table we give 0 as input, its output will be 1. If we give input as 1, the output will 0. Then coming to the universal logic gates, in universal logic gates we have two types, they are NAND gate and NOR gate. In NAND gate, a NAND gate is constructed by connecting a NOT gate at the output terminal of the AND gate. The output of NAND gate is high, that is 1. If at least one of its inputs is low, that is 0. The output of NAND gate is low, that is 0. If all of its inputs are high, that is 1. And these are the logic symbols. In first logic symbol, we give two inputs and we get one output, and in second symbol we give n number of inputs and we always get one output. In the truth table, we give 0 to both two inputs, we get output as 1. If you give both inputs as 1, we get output as 0. Then coming to the NOR gate, a NOR gate is a constructed by connecting a NOT gate at the output terminal of the OR gate. The output of OR gate is high, we take it as 1. If all of its inputs are low, we take it as 0. The output of OR gate is low, we take it as 0. If any of its inputs is high, we take it as 1. And these are the logic symbols. We give two inputs and we get one output, that is y is equals to a plus b bar, and we give n number of inputs, we get y equals to a plus b plus 1 plus n bar. Then coming to the truth table, we give input as both inputs as 0, we get 1. If you give 0, 0 for one input and 1 for other input, we get 0. As like for we give two inputs as 1, we get 0. Then coming to the other logic gates, we have XOR gate. This logic gate which gives high output, that is 1 if either input A or input B but not both are high, that is 1 is called exclusive OR gate or the XOR gate. It may be noted that if both the inputs of the XOR gate are high, then the output is low and that is 0. Then coming to the logic symbol, these both gates are interconnected to each other. At the truth table, the same inputs like 0, 0 or 1, 1, they get output as only 0. If we give 0 as one input and 1 as other input, it will come output as 1. Like vice versa, we give 1 as the first input and 0 as second input, we get it output as 1. Then coming to the XNOR gate, this gate function implemented by a two input XNOR gate is given as when both A and B are the same, will give an output at Q. In general, an exclusive NOR gate will give an output value of logic 1 only when there are an even number of ones and the inputs to the gate. The inverse of the XOR gate, except when all its inputs are low. Here in the logic symbol, XOR gate and NOT gates are connected to each other. We give two inputs and we get one output as Q equals to A plus or B bar. And the truth table is we give uh, we give inputs as 0, 0 or 1, 1, we get output as only 1. If we give inputs one is 0 and another input as 1, we get it 0. And we give input as 1 and other input as 0, we get output as 0. And those are the detailed information about the logic gates. And here is the logic gates and their ICs, IC number, and we have the name of the gate. For NAND gate, the IC number is 7400, and for NOR gate 7402, for NOT gate 7404, and gate 7408, and OR gate 7432. Then XOR or XOR or 7486 is the IC number, and XNOR or XNOR, their IC number is 74266. These are all about the logic gates in detail. Thank you.